AI.
What up, folks, and welcome to Cyberstruck, episode 5. Today I have for you two amazing artificial intelligence updates happening right now in one of the things that you probably do every single day, driving. And before we get started, let me give you a small teaser on what we'll be seeing today: autonomous driving and recognition of emotions inside the car. So, let's dive right in. Pandemic aside, driving has become a part of our society for many daily activities. You may need it to go to work, or perhaps your work itself requires driving, but it also simplifies a quick weekend getaway so much. And let's be honest, it can be such a pleasure being behind the wheel when one is fresh and enjoying a clear sunny day. However, driving can be a real nightmare if you're tired, drowsy, or simply going through a bad moment, right? And this is no joke. Around 1.35 million people die every year in car accidents, and 20 to 50 million people suffer non-lethal injuries, often resulting in long-term disabilities. And it is no surprise that distracted driving causes 1 out of 4 accidents in the US, while inebriated or drunk driving accounts for 20% of fatalities in high-income countries and up to 69% in low to middle-income countries. If we look at it from the economic point of view, car accidents cost around $518 billion every single year, which is almost the GDP of Sweden. However, automotive engineering has developed by leaps and bounds from the first Ford Model T back in 1908 to current cars, and this includes safety engineering. Seatbelts came around in 1950, and today they prevent 45% of fatal injuries to front passengers and 50% of moderate to critical injuries. Literally a lifesaver. The first airbags came into play 24 years later, in 1974, and according to the National Highway Traffic Safety Administration, they prevent 14% of fatalities. Other onboard systems watch for our safety when we're on the road. Take the electronic stability control as an example. Cars with ESC are 32% less likely to be involved in single crash accidents and reduces the probability of rolling over by 58%. So what's next for road safety? Well, hang on, because we have for you the most mind-blowing artificial intelligence happening right now in the next generation cars. From autonomous driving to emotion recognition of the passengers on board to assess potential risks. Self-driving cars have been a concept that has been lingering for ages, from the cartoon folklore to partial achievements from legacy automakers like GM and Ford. Still, reaching full autonomy, or FSD level 5, whereby the car is capable to drive itself given any roadway or environmental condition without the need of human intervention, is quite the challenge. Think about it for a moment. As a driver, how many risky scenarios can you think of when you're behind the wheel? Pedestrians crossing the road on a red light because they are distracted with their phones, unprotected left and right turns that can cross multiple lanes, traffic signs that are unclear or partially visible, and a whole bunch of different situations that can challenge the most experienced driver. And in this regard, it is really impressive to see what the energy and technology giant Tesla has achieved with its beta self-driving release. Tesla's Autonomy is purely based on visual recognition through the 8 integrated 360-degree cameras in their vehicles, which act as a data feed for Tesla's artificial intelligence neural network at an astonishing speed of 144 trillions of operations per second, or TOPS. Companies like Uber, Waymo, and MobilEye are also in the race towards achieving autonomy, but keep in mind that instead of visual recognition, they use a completely different approach, which is light detection and ranging, or LIDAR. The way LIDAR works is by emitting pulse light waves off the car and into the surrounding environment, and measure how long it takes for these pulses to come back into the car sensors so that it can recreate a 3D map of the surroundings. And you may be asking yourself, but isn't that basically the way radar works? And rightly so. But the main difference between LiDAR and radar is their wavelength. While radar wavelengths usually range from 30 cm to 3 mm, LIDAR wavelengths are much smaller, going from 905 to 1550 nanometers. And it is precisely the small wavelength that constitutes the weakness for LIDAR in bad weather conditions, such as rain, fog, or in reduced visibility like nighttime, because it can easily create fake echoes. A solution proposed by Tesla CEO Elon Musk to overcome this is using an occlusion-penetrating wavelength of around 4 mm, like radar. Let's hear why Tesla's director of artificial intelligence, Andrej Karpathy, believes that visual recognition is the right approach to achieving self-driving autonomy.
So in summary, people drive with vision only, no lasers are involved. This seems to work quite well. The point that I'd like to make is that visual recognition, and very powerful visual recognition, is absolutely necessary for autonomy. It's not a nice to have. Like, we must have neural networks that actually really understand the environment around you. And LIDAR points are a much less information-rich environment. So vision really understands the full details. Just a few points around are there's much less information in those. So as an example, on the left here, is that a plastic bag or is that a tire? A LIDAR might just give you a few points on that, but vision can tell you which one of those two is true, and that impacts your control. Is that person who is slightly looking backwards, are they trying to merge into your lane on the bike? Or are they just going forward? In the construction sites, what do those signs say? How should I behave in this world? The entire infrastructure that we have built up for roads is all designed for human visual consumption. So all the signs, all the traffic lights, everything is designed for vision. And so that's where all that information is. And so you need that ability. Is that person distracted and on their phone? Are they going to walk into your lane? Those answers to all these questions are only found in vision and are necessary for level 4, level 5 autonomy. And that is the capability that we are developing at Tesla. And this is done through combination of large-scale neural network training, through data engine and getting that to work over time, and using the power of the fleet. And so in this sense, LIDAR is really a shortcut. It sidesteps the fundamental problems, the important problem of visual recognition that is necessary for autonomy. And so it gives a false sense of progress and is ultimately a crutch.
All in all, think about it for a moment. Tesla is aiming for their cars to literally understand the surrounding environment, to make driving without any sort of human intervention possible anywhere in the world. And we will most likely see in the upcoming years a fleet of Robotaxis where anyone will be able to summon a taxi and drive by itself to your destination. And in doing so, once we have autonomy level 5, we are expecting that driving will become much safer and cheaper ride-hailing, since there won't be a need for a human pilot. But of course, some drivers may not want to give up the control of their vehicle. So, ladies and gentlemen, let me introduce you to Affectiva AI. Affectiva AI, an artificial intelligence that can identify in real time the emotions and states of the passengers on board. This deep learning software monitors in real time the state of the cabin, assessing the emotions and cognitive states such as drowsiness, anger, use of mobile phones and objects in the vehicle. Affectiva AI has recently been granted 2 new patents in relation to improving the assessment of the condition and state of the driver, which include drowsiness mental state analysis using blink rate. Drowsiness, mental fatigue, attention, and cognitive load are determined based on temporal analysis of an individual's blink rate. This information can be used to manipulate vehicle operation, including recommending a brake, adjusting the in-cabin environment, and activating braking and steering control. And 2, cognitive state evaluation for vehicle navigation, which influences vehicle control via multimodal sensing of occupants' cognitive states. The analysis is performed using signals like speech and non-speech vocalization, such as yawns and snoring, and physiological data including heart and respiration rates. To date, Affectiva has been awarded 39 patents and has more than 25 still pending, with more than 10 million faces analyzed. And now it is your turn to tell us, how do you feel about these 2 artificial intelligence developments taking place inside your car? Are you willing to let your own car drive while you read a book? And do you think the benefit of this AI reading your condition and emotional state too little compared to the risk of having your own privacy taken away? Let us know in the comments. Hope you enjoyed this episode of Cyberstruck. Do take care and see you very soon.